This week, SpaceX quietly filed paperwork for what could become the largest infrastructure project humanity has ever built. Bigger than any railway network, bigger than any power grid. 100,000 satellites, a signal network designed to do a lot more than give you internet. This one is built to power the entire AI revolution. It's called Gen 3, and today we're breaking down exactly what it is, why it's such a massive bet, and what it means for AI companies, investors, and the rest of us. On July 6, 2026, SpaceX filed an application with the U.S. Federal Communications Commission requesting authorization to deploy up to 100,000 third-generation satellites, what's being called the Gen 3 constellation. To put that number in context, SpaceX's current Gen 2 system is only authorized for 15,000 satellites. If Gen 3 gets approved, that's roughly 6.7 times bigger than what's already up there. Each satellite will weigh around 2,000 kilograms, so heavy that only one rocket on Earth can lift them, SpaceX's own heavy-lift Starship. These satellites will sit in two orbital shells, one between 323 and 327.5 kilometers, the other between 473 and 477.5 kilometers, placing them in what's called very low Earth orbit. Here's the real twist. This constellation isn't primarily built for broadband. SpaceX's own filing states that AI applications will require massive uplink capacity to support real-time decision-making and industrial automation at scale. Think about it this way. Every time you ask an AI assistant a question, stream a recommendation, or rely on an autonomous system, that's data moving in real time. Right now, most of that runs through ground-based fiber and towers. SpaceX's bet is that the next wave of AI, the kind running factories, self-driving fleets, and billions of connected devices, will need bandwidth that ground infrastructure alone can't deliver everywhere on Earth. In other words, these satellites are meant to feed data to future AI devices, autonomous systems, and industrial automation in real time. This isn't a broadband upgrade. It's essentially a nervous system for AI wrapped around the entire planet. And that AI-first framing matters because investors assign massive valuations to anything tagged as AI infrastructure right now, whether that's data centers, chips, or apparently satellites.
The financial angle here makes this even more interesting. SpaceX's buildout has been accelerated by its recent $85 billion IPO cash raise, which reportedly pulled the timeline forward by roughly 2 years. And this isn't an isolated move. SpaceX recently acquired Anysphere, the company behind the AI coding tool Cursor, in a $60 billion all-stock deal. Market analysts believe this acquisition is meant to give SpaceX the AI software engineering capability it needs to intelligently operate these massive satellite networks. So the picture becomes clear. Satellites, AI compute, and AI software. SpaceX is building a vertically integrated AI infrastructure empire, not just a rocket company anymore. And the competition isn't sitting still either. China has already filed plans with the International Telecommunication Union for its own constellations totaling nearly 200,000 satellites. Blue Origin is also working on large constellations of its own. This has stopped being a single company's project. It's become a global race for AI infrastructure dominance, and it's happening in orbit. But not everyone is celebrating this. Astronomers have raised concerns for years about how satellite megaconstellations affect the night sky. Bright, fast-moving objects that interfere with telescope observations and long-exposure imaging. As constellations scale from thousands to potentially hundreds of thousands of satellites, those concerns only grow louder. There are also questions about orbital congestion. More satellites means more potential for collisions and space debris, even in low orbits where objects tend to burn up faster. SpaceX has stated it intends to meet or exceed existing orbital debris mitigation rules and says it will continue working with the astronomy community. But as multiple countries and companies race to build their own mega-constellations at the same time, the bigger question is whether regulation can keep pace with how fast this is scaling. And Gen 3 isn't even SpaceX's biggest play.
In a separate filing, SpaceX has already proposed a 1,000,000 satellite orbital data center constellation, nicknamed Starmind. Elon Musk has described it as a first step toward what he calls a Kardashev Type II civilization, one capable of harnessing the full power of the sun. These satellites would run as data centers powered directly by solar energy in space, without the environmental cost of a terrestrial data center. So when we talk about 100,000 satellites, we're really only looking at one piece of a much bigger puzzle, an infrastructure layer that ties together AI compute, global connectivity, and a space-based economy all at once. So next time your phone connects to Starlink, remember, that's not just an internet signal. That's a signal from a trillion-dollar infrastructure race that will decide which company, which country, and which orbit ends up controlling the future of AI. Deep space isn't just a story about stars and galaxies anymore. It's becoming a story about our own economy, too. If you enjoyed this deep dive, hit subscribe, because on Deep Space Signal, we break down what's really happening in space every week and what it means for you.